Hey, sixth grade. As you have probably ascertained, I am not there today. There's just a couple of medical things that I have to take care of today, so nothing is terribly wrong, but it just means I can't be on my feet. So, what I've done is, of course, I've posted everything to Google Classroom, as you can see here, and I just wanted to provide this video so that if you're not, if the directions in your packet don't make sense, you have something else to refer to. But here is the packet for today. Looks like this. And of course, we're going to start with the content connections video. So you do want to go ahead and log into Stemscopes, and this time you will be doing it on your own. Just a reminder that when you go to do that, see that I post that here as well. So you're looking for this content connections video, has the little earbuds. Your list is probably getting very long at this point. So just remember that you're going to want to look for the little title underneath the word content connections video to know which one you're looking for. But just as we've done in class, when you click on this, you have down here where you can turn your captions on. And if you want to watch it full screen, you can, of course. But the captions are really helpful. I still recommend that you kind of go through and just read these questions to yourself. Question 1 says, what is the theory of continental drift? Question 2 says, what two observations that supported the theory of continental drift? Number 3 said, what are divergent boundaries and what do they create? And number 4 says, what is a transform boundary and how does it affect the land? You are still not answering the questions here in Stemscopes. You're going to answer them here on your packet. Okay, so all those questions are here as well. But, if you want, they're there for you to look at if you want, or have the reader read it to you. So that is the first part of that. The second part is going to ask you to go to dive and discover plate tectonics. So that link is here in Google Classroom. It's right here, plate tectonics, dive and discover. And when you open that up, it's going to take you to this page of interactives. The breakup of Pangea, I think the first part of the packet asks you to watch the animation of that. It's very short. It's just like a minute. But if you open that up, you'll see there's just a little video here that you can watch. It's 15 seconds long. So just watch. All it shows is how the continents looked when they were all together and then how we think they spread out over time. And then you're going to come back and you're going to do this one. And you may remember this. We did this during school last year. This map is just cool because it has these various layers that you can turn on and off by clicking these buttons. Okay, and there's no magic to the order that you do these in, but it is, this one shows the plates and all their names. This one shows the boundaries between the plates and where they come together. This one shows which direction each one is moving. So the Pacific plate is going this direction, so you can see the arrows going that way. North American plate is kind of going down here. The Nazca plate and the South American plate are kind of running into each other. Okay, that's important. We'll talk about that. Notice that the plates along this line are moving away from each other. So Africa is moving this way, South America is moving this way, and so on. Okay, so that's the things you want to kind of notice, like Australia is moving up. These are just the directions that they're moving as far as we can tell. Vent field shows you where there are volcanoes that are regularly erupting lava. Major earthquakes are dots where the major earthquakes occur, and that comes up in your activity. Fault zones show just kind of where there's a lot of breakage going on, which is always at the edges of plates. And then subduction zones shows where one plate is sliding under another one. So for example, because Nazca and South America are running into each other here, the Nazca plate is kind of running underneath the South American plate. That's a subduction zone. So on these lines, notice that there is a line here and there's sort of arrows pointing towards South America. That's showing that the plate that is being subducted is moving towards South America. It's not that South America is getting tucked under the Nazca plate. It's the other way around. Nazca is getting tucked underneath South America. And that is why South America has all the mountains that they have all along here. Okay. So the questions you're supposed to answer, first of all, watch the animation and answer question 1. It says, watch the animation of the breakup of Pangea. In particular, notice the movement of India from Africa up to Asia. What do you notice? It is kind of a cool thing to look at a map of India now and look at what it looks like now that it has crashed into Eurasia, because that's how we got the Himalayas. On question 2, turn on the plates, plate boundaries, plate movements, and subduction zones. So we're going to go here. We have plates, plate boundaries, plate movements, and subduction zones. So your map for number 2 should look like this. Okay. And the packet asks you to identify which plates are being subducted. So as we discussed, South America is subducting which plate? Okay, so we have here, the Nazca plate is the one that's getting tucked underneath. So Nazca plate is number one. Okay. Up here in North America, which plate is getting subducted underneath North America? And then Eurasia is subducting several. So try to figure out which plates are all going underneath this plate here. And now click on major earthquakes. What do you notice about where the majority of major earthquakes occur? Okay, so you're just going to come here. You're going to click that one and then think about how that relates to the other information that's on here. Okay, so that's all you do for that. For of course, the Stemcopedia, you are going to go back to content connection, or go back to Stemscopes, go back to your assignments list. It is there. Now that they're getting kind of long, notice that we have explain and engage tags. The engage tags are all the videos. The explain tags should be all of your Stemcopedia articles. If you click on this, like right now, this is my test person, so they don't have them all assigned, just this one because I was going to discuss it. But if you click on explain, all the Stemcopedia articles that you have should show up together. It makes it easier to find the one you need. But you want the one here that says plate tectonics. So you're going to click on that, open it up. And again, these are scaffolded notes. So everything is in order. Okay, everything that you're being asked to do. What is a lithosphere? What are tectonic plates? They're all more or less in order here. Sorry, my puppy's crying. Okay, so that's what's going to go on page 2. You're just going to kind of read through this. Fortunately, it's actually not that long. There's a lot of very large pictures in here. So most of the text is actually pretty short. And just a reminder that whenever you're doing these, remember that you have these tools here, and notice that they are following me down the page. So you can click on this to make the text larger if it's hard to see on your screen. You can click on this to turn these play buttons on, and they will read it aloud to you so that you can listen to it instead of having to read it for yourself. If you run into a word that you don't know how to define, like the word lithosphere here, you can click on the dictionary, click on the word lithosphere, and it will pop up a dictionary definition of it with a player. So if you wanted to read it out loud, you can. So that's something else you can do. The highlighter is really handy if you use it the way we've talked about all last week. So I talked about this a little yesterday in class, but just a reminder that what you do is remember we talked about underlining the first lines of any paragraphs that contain really good information, underlining all of the, I'm going to turn this off so those are out of the way, all of the definitions of bolded or italicized words, and then anything else that looks like it might be really important. So for example, the crust is the top layer of our surface, the core is the center layer. So I think that's a pretty important one. I'm going to go up here, I'm going to click on this, and I'm going to click on, well, actually, sorry. And what I'm going to do is highlight this with my mouse, drag across, and this will pop up for you so that you can choose what color you want. And what color you use is completely up to you. If you really like green, which I do, I choose green. Some people will use like yellow for the beginnings of paragraphs, green for different definitions, blue for just important stuff that they want to remember, that sort of thing. So you can use this as your own color coding. That's completely up to you. But the nice thing about this is that once you've done that and you've put those highlights into place, up here at the top, if you come back to this later and you need to find information, you can click 2 different highlights here. So if I scroll back up to the top and I come here and I click next highlight, it's going to move it so that thing I highlighted is right at the top. So I do recommend that you do this. I'm not necessarily going to be checking this time. So your points for this one are not going to come from the underlining like they did last week. But it's a good habit to get into. It's also helpful to you in the long run because this is going to be your reference point when you're trying to study in the future, if you were taking a test in 7th and 8th grade. So just keep that in mind. That's what you're going to do for that one. And then for page 3, we're looking at these 2 videos. How do we know plate tectonics is real? Okay, and this is a video that we watched a couple times last year because we liked it. He's got a lot of really corny puns in it. That link is also here in Google Classroom. How do we know plate tectonics is real? And then the second one is how one brilliant woman mapped the secrets of the ocean floor. Again, both of these videos are about 4 minutes long, so neither one of them is a very long video. But that video is also here, How One Brilliant Woman. So this is the story of Marie Tharp, who discovered the Mid-Atlantic Ridge. So that's a good one too. Okay, so that's what you're going to do. You're going to read out these 2 Google Earth links that are also listed here. And the first one should take you to a Google Earth project that shows the seafloor age color-coded. The oldest seafloor that we have still existing, as far as we know, on the planet is actually not located in one of the oceans. It's located in a sea. So if you look, just look for the color, look at the menu here on the side. Actually, I'll open it so that you guys can see what I'm talking about, because that would make more sense. Takes just a minute for Google Earth to load. There we go. Okay, so notice here we have this menu here that tells you how old they are. So Quaternary is the most recent, so the red stuff is the newest, and the bluer and greener stuff are the things that are older. So the Triassic, Jurassic, and Cretaceous, these are the dinosaur eras. So all of these, yellow, orange, those would have formed during the Mesozoic era when the dinosaurs prevailed. But notice that, there's a lot of green over here. This is all Jurassic era stuff. And then, anything orange or older. So what you're looking for is something down here in the blue. So you want to kind of circulate around, try to find the blue. Now, it's not these lakes. Okay, those lakes are not part of this scenario. Okay, so just keep that in mind. The other link is going to take you to another Google Earth project that shows you where all of the earthquakes have taken place, volcanoes, I think. 10,000 years of volcanoes. So it also kind of goes along with what we saw in Dive and Discover. What do you notice about the Ring of Fire here, where you can see where they're all around the Pacific Plate? So so that's what you're going to look at for that. That's why there are so many links for today. Now, fortunately, that's the last link. The last part of this, of course, is your evaluation piece, and that's where you're going to be using this diagram to answer the questions below. Okay, so we want to look at, this is going to describe two different land masses that were close together. You're going to look at the fossil evidence and describe which of the fossils suggest that this was the case. So in this case, South America and Africa were once connected. We have this fossil, which is the Cygnognathus, the Galisopterus fern here. It also shows that, and so does Mesosaurus, this one right here. Okay, so those three, since they both share them, those are the three things you're going to put right here. Okay, so you're going to fill in those other two on your own. All right, I have GoGuardian up. I will be out at another medical appointment about between 10 at about 10 o'clock. So third hour, I will not be as accessible to you all, but I will have GoGuardian up all the way through 2 o'clock. So as soon as I'm back, if you have questions, you can ask me questions that way. Hope you all have a great day. Take care. Bye.